sort of closed system surrounded by a horizon, and that horizon behaves roughly like the horizon of a black hole.
Black holes are our powerful gravitational engines that are so dense that nothing, not even light, can escape their pull.
The classical story of the increase of entropy misses part of the evolution.
They can devour stars, warp space and time, and create gravitational waves that ripple across the universe. But what if we could use them for our own benefit? What if we could extract energy from them and use it to power our civilization? Or even make a weapon? Yeah, let's avoid that second option for now, please. I really want to know what you think. Leave a comment below. What would you do with black hole energy? And hey, if you like this space talk, give us a like, hit that subscribe button, and come along with us on our interstellar journey. Well, some physicists have thought about this, and they've come up with some interesting and crazy ideas. One of them is called the Penrose process, and it was invented by a guy named Roger Penrose in 1971. I know I said it casually, but he is one of the most valuable physicists of our time.
But there's something almost paradoxical about this microwave background. It's telling us that there was something like the Big Bang there.
And he discovered that if you have a spinning black hole, you can use it as a giant battery. How? Well, it's a bit complicated, but it has something to do with brane dragging. Basically, when a black hole spins, it drags the surrounding space along with it like a whirlpool. This means that if you throw something into the black hole, it will get a boost from the spin and come out faster than it went in. Faster than light, in fact. Yes, you heard me right, faster than light. Don't freak out, this doesn't break any laws of physics because the thing is not really moving faster than light, it just looks like it from our perspective. But it does mean that it gets a lot of energy from the black hole's spin. Alright, let me break down the Penrose process for you. No physics degree needed. We're here for the fun of learning cool stuff, and I don't have that fancy degree either. So how does this process work? First, you need a spaceship that can fly near a spinning black hole. Not just any black hole, mind you, but a really big and fast one. Then you need to enter the ergosphere of the black hole. What's the ergosphere, you ask? Well, it's a region around the black hole where space is so twisted that everything inside it has to spin along with the black hole, whether it likes it or not. It's like being on a merry-go-round, but you can't get off. Except it's not merry at all, it's terrifying. Once you're in the ergosphere, you need to drop some mass or radiation into the black hole and use the kickback to boost yourself away from the black hole. This way you can steal some of the black hole's energy and slow down its spin. This process can give you up to 20% of the black hole's mass energy, which is a lot, like a lot. To put it in perspective, fusing hydrogen into helium only gives you about 1% of the mass energy. So you could use this process to power your spaceship by dropping a lot of mass or radiation into the black hole and collecting the energy from the particles that escape. Sounds like a piece of cake, right? Wrong. There are some major hurdles to overcome. First, you need a very large and fast spinning black hole, which are not very easy to find in nature. Most black holes are either too small, too slow, or too far away. Second, you need a perfect and synchronized move to pull off the Penrose process. But that's easier said than done. The environment near a black hole is so chaotic and dangerous that you could end up being spaghettified, which is when you get stretched into long noodles by the black hole's gravity. And trust me, that's not a fun way to go. And last but not least, you have to find a very efficient and robust way to collect the energy from the particles that escape. That's no easy task when they're zooming around at crazy speeds and going in all directions. You need to catch them all, like Pokemon, but with more physics and less fun. But what if we could pull it off? Just imagine the amazing things you could do with the energy of a black hole. You could build a warp drive, or even a wormhole generator, and travel across the galaxy in a flash. You might even consider a time machine zipping through history, like it's a Netflix series. The possibilities are endless. But remember, with great power comes great responsibility. One wrong move, and boom, we are gone. I bet you're wondering, we can barely go to the moon, and some people even doubt that. How can we go find a black hole and use its energy? Yeah, that makes sense, and you're right, we have a very long way to go. But what if I told you there is another crazy method that's much more achievable than using a black hole? Do you have a guess? Well, the answer is right in front of us. Literally, it's the sun, the ultimate source of energy in our solar system. The sun radiates more energy in 1 second than humanity has ever used in history. Imagine if we could harness that energy and use it for our needs. How awesome would that be? Imagine a giant shell that surrounds a star, capturing all of its energy output and turning it into usable energy. That's a Dyson sphere, a mind-blowing megastructure that could provide a civilization with endless power. Think of what you could do with that power. You could light up cities, fly spaceships, create artificial intelligence, transform planets, and travel across the stars. You could do anything you want. Well, almost anything. But building a Dyson sphere would be the ultimate achievement of a civilization, requiring the skills and knowledge of many fields of science and the resources and energy of many worlds. So how do we measure the power of a Dyson sphere and the civilization that builds it? Well, there is a scale for that, and it's called the Kardashev scale. The Kardashev scale is like the Olympics for civilizations, grading them on their energy game. We start at Type 1, using all the energy of our planet. Not bad, right? But the real fun starts at Type 2, where we get our energy from our star. And hold on tight, because a Type 3 civilization can use the energy of a whole galaxy. Now, to go from Type 1 to Type 2, we need to get close to the sun. And I don't mean sunbathing. That's where a Dyson sphere comes in handy. This huge structure surrounds the sun and collects all its power. It's like having 1 trillion nuclear reactors, but powered by the sun. The problem? Building this thing is a huge challenge. Imagine a project so big that it makes skyscrapers look like Lego towers. But hey, if we pull it off, we're talking about more power than you can imagine. And we're not talking about some of it, we mean all of it. And the most realistic way to do it is not with a solid shell, but with a swarm of satellites that orbit the sun and catch its rays. These satellites could be simple and light, like giant mirrors that focus the sun's heat on a spot, where it could be turned into electricity or sent across space. Sounds awesome, right? Well, there's a catch. To build this swarm, we would need about 30 quadrillion satellites, each the size of a square kilometer. That's more than the surface area of Earth. Where would we get all that material? Well, the answer is Mercury, the closest and most metallic planet to the Sun. Mercury has no atmosphere to slow us down, and its gravity is only 1/3 of Earth's, making it easy to launch stuff into space. Now, what if we could use all the fossil fuel on Earth to send satellites to the Sun? Do you think it's possible? Indeed, it's not. Even if we burned every drop of oil, gas, and coal and ran every nuclear reactor at full blast, we would still fall short of the energy needed to build a Dyson swarm. Well then, what shall we do? I believe the answer can be found on our YouTube channel, Sagan's Sandbox. It might also be the key to make humanity an interstellar species. Okay, not really. I'm just promoting our channel right now, don't mind me. But seriously, there are a lot of high quality videos waiting for your click. Just check them out. You can start with this amazing one in the middle of your screen. It might be the most surprising video you'll see today. And before you leave, if you enjoyed our content, don't forget to like and subscribe for more space videos. Thanks for watching, and see you soon.